You're listening to the Common Descent Podcast.
Hello, Will.
Hello, David.
Hello, everybody, and welcome to the Common Descent Podcast, a podcast about paleontology, evolution, and the fascinating history of life on Earth. This is episode 191. This episode's topic is language.
Yeah.
This is a long-awaited episode. Not only has it been requested a bunch by our listeners, but also I've wanted to do this episode for a long time.
Yep.
But indeed, I will not be doing this episode in the traditional sense. We will be joined for the discussion by returning guest to the podcast, Dr. Bridget Alex, paleoanthropologist who joined us for our Neanderthals episode, 177, and is back to talk about language. We'll talk about what language is, the diversity of it, what counts as language, what are the parallels we see elsewhere in the animal kingdom, and how we understand language of the past.
Yeah, I had a lot of fun in this one talking about, where do you draw the line on what counts as language? It's super fun.
Also, this has happened a couple of times in the podcast that it is very self-referential to do a podcast about language.
Oh, yeah.
I don't have any deeper thoughts on that. That's just a thing that's fun.
Well, to use the thing you're discussing to discuss the thing you're discussing.
Yeah, absolutely. This topic was requested a bunch of times by the following requesting listeners: Ollie, Kieran, Shannon, Andrea, Philip, Michael, Milu, Ned, Kylie, Jack, and Gazeboist. Thank you all so much for your requests.
You have excellent taste.
Before we get into our languaging about language, there are a few announcements for us to discuss. Number one, as always, we have a Patreon.
Mm-hmm.
You can find a link to that Patreon down in the episode description, where you can also find a link to our website, and on the website you can find a link to our Patreon. The support that we get from our patrons allows us to do the whole podcast. It is our utter delight to be able to deliver consistent scientific educational discussions for anybody who wants to listen to them, and it is thanks to our patrons that we're able to continue to do that. In return, patrons who support us get access to bonus content. We do bonus news, we do live streams, we have director's notes for the episodes, there's a whole bunch of cool goodies, shirts and stickers, all sorts of cool stuff. But the reward that you already know about, if you've listened to the podcast before, is that at a certain level we will shout out the names of new patrons right here on the podcast. This episode we will like to welcome new patrons: DXPO, Steph, Amanda, Laura, and Yvette.
Welcome and thank you for your support.
Welcome and thank you to our patrons, old, present, and future? Question mark, could be you. We've got a bunch of other stuff that's been going on with the podcast recently. Last month in April, we released 3 episodes of Silver Screen Science talking about shark movies, which was a whole ton of fun. On Patreon, we also have more thoughts episodes for each of those Silver Screen Science discussions, where we leave the science behind and talk about our more thoughts. We did a live stream for Silver Screen Science, which was a whole bunch of fun, interacting with our guests.
Wonderful. I had a ton of fun with that one.
So we'll probably do more of that kind of stuff in the future. Also, as of this episode's release, there are 3 episodes out of Spotlight 2024. Our series where we sit down and talk with other paleontologists and podcasters about podcasting and science communication. 3 episodes out, several more to go. Tune in on those if you haven't already. Also, it's May now, which means next month is June, and then after that is July, and that's Croc and Snake Month.
Yep.
As with every year, we'll be doing some special stuff for Croc and Snake Month, including themed episodes, but also we will be bringing back the special tier on our Patreon, where subscribers to that tier will be contributing to charitable donations that we will be making at the end of the summer to the conservation efforts for our favorite reptiles. So stay tuned and join us to celebrate crocs and snakes across the summer.
Yeah.
One more thing on the note of cool interactions with our listeners. We got gifts.
Yeah, we did.
We have a mailing address that you can find on our website that you can send us cool stuff if you want to. We got a lovely letter from Audrey along with a poster of really cool animal artwork from Elena.
With some fantastic animals on it, so I'm very happy with the
Great
selection.
Great choices of animals to put on there, and lovely art.
Yeah, it's pretty.
And we got letters and postcards, as it were, from Elizabeth.
Yeah.
Thank you all so much. We really appreciate you reaching out and sharing little bits of your lives with us.
Yeah, it's always fun to get mail, and especially from you all listeners, so thank you.
Them's the announcements. Time for the news. Every episode, we like to kick it off with some news, new research and science in the realms of paleontology, biology, and related sciences. I'm fully out of words. Will, news.
Orangutan medicine.
Okay.
Yeah.
Just a little bottle with an orangutan's face on it. Orangutan branded medicine.
Yes, yeah. It was the thumbs up.
Dr. Zayas.
Orangutan approved. Dr. Zayas.
Help me, Dr. Zayas.
Dr. Zayas. This is a new finding.
I'm laughing about the Dr. Zayas thing. New finding. Keep going.
About an orangutan using medicinal leaves to heal a wound on its face.
Yeah, I saw this.
This is super exciting.
Someone shared this on our Discord.
Yeah, it's awesome. This is research by Isabel Laumer et al. In Scientific Reports, and the article is by Georgina Reynard in BBC News. So, self-medication is a thing that we pay attention to because that's one of those, like tool use, that's one of those things that we thought was only human, among other, that we have found more and more of similar or parallel uses in other primates. So it's something we keep an eye on because we want to know where is that difference between us humans and other apes, and what might be shared among primates or just great apes. And there have been other times of apes and primates showing medicinal usage of plants in ways, like eating medicinal plants.
Right.
Like eating particular plants known to have helpful attributes, or chewing on them, just chewing the pith of the plant and getting that juice going. This has been noticed in the African great apes, orangutans, and white-handed gibbons, evidently, and some other species of monkeys. But it's always been, many of those have been like suspected, or we don't know for sure that is why they're eating. This is a fairly straightforward, it seems, situation of an orangutan using medicinal leaves in a unique way. This is a Sumatran orangutan, a large male named Rackus, who at some point got a pretty nasty wound on his face.
Yeah, like on the cheek.
Yeah. Like right under the eye.
Ugh.
Yeah. It was right near the nose. They suspect it was probably a wound inflicted by another rival male, because evidently Rackus had been doing what were called long calls, which are like territorial or challenging calls, it sounded like. So it's likely that they got into a fight at some point. 3 days after the injury, they noticed Rackus selectively ripping off leaves from a liana, which has the common name Acar kuning, which is a known medicinal plant. They watched Rackus chew the leaves and the stems for quite a while, and then applying the juice that was produced with their finger onto the wound. Like over and over again, a number of times, and then eventually fully smeared the chewed leaf across the wound. Continued to feed on the plant for, they said, 30 minutes, and then within, it said within a month, but the news article also said that within 5 days it had started to close up, but within the month it had closed and basically healed up, which seems like very purposeful medicinal use.
Yeah, this isn't just like an accident you got a leaf on your face. This is repeatedly rubbing the juice and the leaves on that wound specifically.
And this is supported by a number of lines of evidence. One, orangutans are not known to particularly feed on that plant otherwise.
Sure, so it's an unusual plant to be chewing on.
Yes, they're not typically eating it, so it's not like he was just playing with the food. It seems Rackus was actively selecting this plant. And it was a lengthy behavior. It was something that Rackus did for quite a while. It wasn't just a passing, I grabbed some leaves, chewed them, and then left. So it seemed purposeful and an out of character, so to speak, behavior, which seems like they were doing it for a very particular reason. They also noticed that Rackus was resting more for longer periods during this time, probably trying to recuperate. So it seemed like it was
because they were hurt.
So it seemed like there was mindfulness about this wound. There was behavior shifts otherwise as well. This liana species is known. It's found throughout tropical forests in Southeast Asia and is known to have a number of medicinal uses. It's used to treat diseases like dysentery and diabetes and malaria by the peoples there. So it is already known that it is actually useful for this kind of stuff. They analyzed the plant to see how it would affect with application to an open wound and found that it did have antibacterial, anti-inflammatory, antifungal, and antioxidant features.
Okay.
So it absolutely would help.
It works as a poultice.
It also likely would have had pain relief to it as well, which leads to a number of speculative situations as to what might have been happening here. This could be something that Rackus invented on their own. Came up with, either did accidentally or had come up with on their own. This could be the first time. It could be multiple times that they've done this. It could be something they discovered by accident. If they just happened to get the juice on and touch the wound and it did have pain relief.
Right. If it just felt good.
If it just felt good, well, then keep doing it.
And then you just keep doing that.
Keep doing it. It could have been something that they learned from other orangutans.
Sure.
Their parents
will do that.
They're the adults that they grew up with or other members in the group. So absolutely, it's something that could have been passed down. But they pointed out that this could also be something that is ancestral farther back in the great apes.
Right.
That
there's some instinct that is built in to seek out certain plants.
Absolutely. So this could give us some insights into, more early hominid behaviors or instinctual uses of plants that might go back further in our lineage, our shared lineage, so to speak. And they said now the plan is to watch these orangutans much more closely.
Yes, watch the hurt ones.
See if it happens again.
Is this a common behavior?
Mm-hmm. Do they do it in the same way?
Do they do it in the same way? Do different populations do it? Would we see these in multiple populations and multiple species of orangutans? Very interesting. It's one of those things where, like with a lot of other once thought unique to human things, I'm not at all surprised to hear that there are other primates that will apply plants medicinally.
Nope.
Because of what we were saying, at the very least, if you discover that it feels good, like having this juice here for whatever reason makes it feel good because it's a pain reliever or because it's helping to get rid of infection or something, that's a pretty evident and reasonable thing for any animal to figure out to do.
Because it's an instant benefit. It's like animals that use mud as an insect repellent. That's not a long term, that it takes a while for it to kick in. As soon as you cover yourself in mud,
right, no more bugs.
The flies are off of you. That's instant relief.
In a case like this, it would be really interesting to see, not only are these animals regularly doing this, but might we see orangutans bringing this plant to another orangutan?
Yeah.
That knowledge of, I know this plant will help.
Yes.
Or going out of their way to find this plant.
Would parents treat young?
Yeah.
Which
would be very interesting to see.
I'm very excited to see what else we learn about these orangutans. These medicinal orangutans.
Very cool. Well, speaking of secretions, I've got news about frogs.
Gross.
This news isn't actually about frogs per se, but it is about the fossilization process at a particular site via fossil frogs.
Nice.
This is research by Daniel Falk et al. In Scientific Reports. In the blog post, we will link to a press release about this study in Eureka Alert via University College Cork. There are many fossil sites in Europe that are famous for exceptionally good fossil preservation. One of those sites is in Germany. It's called Geseltal, or however a German person would accurately pronounce that. Famous site in Germany, Eocene, around 45 million years old, known for preservation of soft tissue of a bunch of reptiles and birds and mammals and all sorts of really nicely preserved fossil remains, similar to like the Messel Pit and other sites in that region. Geseltal has been classically interpreted as having a unique style of fossil preservation. Not only preserving tissues that don't typically preserve, there are reports of things like blood vessels and cartilage being apparently preserved.
Oh, wow.
But also, previous researchers have described the fossilization process as the silicification of soft tissues. So silica replacing and preserving these tissues, similar to what we'll see in some bones. That would make it a unique fossil site. But from reading bits of this paper, it sounds like these are interpretations that now are quite old in terms of research.
Oh.
This study came forth to assess the fossils and get a closer look with modern techniques and technology to see what we can glean about the taphonomy, the fossilization process, at this site. To do so, the researchers looked at fossil frogs. These are a number of fossils preserved with full body outlines of soft tissues, so remains of the skin and all that around the skeleton. They used such fancy modern technologies as X-rays and microscopy and spectroscopy, and found, for one thing, confirming excellent preservation of soft tissues, including things like collagen fibers, partially fossilized remnants of the endolymphatic sac.
Wow.
And the skin preserved in multiple layers. The layers of the skin, which has been seen at some other exceptionally good fossil sites. But the authors do note that they did not find evidence of other tissues that have been previously reported from this site. So some of those, like blood vessels, stuff like that they might have expected to see from previous studies. They also noted the method of preservation of the skin, preserved in 2 layers with different preservation styles. The outer layer, which is rich in melanosomes, the cellular structures that contain pigments, are highly, what they described as sulfurized, so preserved in this very sulfurous chemical state. And then the second layer preserved in calcium phosphate.
Huh.
Both of which are known from other fossil sites. Like melanin and melanosomes contributing to fossil preservation has been observed before. Calcium phosphate replacement of soft tissues has been observed before. They did not find evidence of silica preserving these tissues, as has been previously reported. So this study, this reassessment, essentially is testing or reevaluating this previous interpretation of how fossils are preserved here, and find that it is excellent, fantastic preservation of soft tissues, but not in a unique preservation style, but in a way that is actually very similar to a bunch of other European fossil sites that have similarly really good preservation.
Okay.
Which is an interesting pattern to find, because on the one hand, it is potentially saying maybe this site isn't one of a kind in that way that we thought it was, but if it isn't, then actually it fits a pattern that is emerging of how fossil sites like this site being less unique actually is more informative for our understanding of how sites like this come to be, because now it's one more of a pattern instead of being its own one-of-a-kind thing.
Yes, absolutely. Which is often the case when we have these moments of like, this thing's not as
singular,
special snowflake as we thought it was. It is actually, a lot of it is falling into patterns we had already noted.
This site might actually fit into this broader pattern.
Yes.
The article in the paper also make note that this is research that was made possible by historic museum collections.
Yeah.
So they were able to revisit this because of these specimens that had already been collected, which is always a really nice thing to get to see and to draw attention to.
Yeah, absolutely. Like, it's not just new fossils that lead to new discoveries.
Mm-hmm.
Having that backlog, or even previously studied fossils that are kept, can let new analyses come along.
Yes.
Which we've mentioned before when it comes to like new technology, but even just...
Oh, sure. And this is one of those cases where it's like, now we've got better technology than decades ago when some of these earlier interpretations were made.
Yeah, so it's now we can get a actually clearer look at them and see them a more truer vision of them.
Yeah. And then we put them back in the drawer, and then 40 years from now, with whatever space technology we have then.
Yeah, when we have the hollow scanners that
Right, and we can reconstruct the whole thing, and then we will know even more stuff.
The chrono scanners.
Right, yes,
That's
exactly. When we have time machines
Yes.
that we can go back.
That's cool.
Yeah.
Oh, I'm still stuck on the multiple layers of skin. That's ridiculous.
That's super cool.
Wow. My next news is also about a very well-preserved fossil. This one, though, is a shark, and it is not the first of this kind, but it has answered a lot of questions about this very weird shark.
All right. I know our animals are getting less and less vocal
Yes.
over the course of our news against the theme of this episode.
We're working away from it so we can come back. This research is by Romain Vullo et al. In the Proceedings of the Royal Society B Biological Sciences, and the article is by Melissa Cristina Marquez in Forbes. This is about a fossil fish, a cousin of sharks particularly, called Tychodus, which is from the Cretaceous. This was an elasmobranch, so cousins of sharks and rays. This one's been known for a long time. It was discovered in 1834, so we've known about it for a very long time, but it's always stood out as a odd specimen for a couple of major reasons. One, it has grinding teeth, like tooth pads, kind of similar to...
More like a ray
than
what we think of from a classic shark.
Absolutely. From the pictures I saw, it looked kind of like a mixture between the way nurse sharks have their teeth set up, where it's lots of teeth, back to back, and then... but in kind of pad situations like rays have them. So they don't have the big flat teeth that rays had, but they had a bunch of teeth in these crushing plates, these crushing pads. And that it was big. About 10 meters long is what the estimates were for all the previous specimens. So this was a large, crushing toothed shark, which is just not typically the combination that you see.
What were you crushing?
Yeah. So the interpretation was that, like other crushing sharks, it was probably feeding down at the bottom.
Sure. Shellfish, mollusks, stuff like that.
But, as is often the case with shark fossils and shark cousins, most of the fossils are isolated teeth with some, isolated vertebrae, but they don't tend to fossilize well because they're cartilaginous, so we'd only get portions of it. This new specimen is recently discovered. It dates to the late Cretaceous of Mexico and is a well-preserved specimen, so it has articulated sections and a preserved body outline in the sediment. So we now actually have a good image of this animal for the first time and reveals a different look than we thought it would have had. First off, they did a phylogenetic analysis to figure out what group of sharks it fits within, and that these seem to be lamniform sharks, which are mackerel sharks. These include great whites and other fast-moving, active-feeding sharks today.
Okay.
It was around 33 feet long, so it was as big as we thought it was, and has the body shape of a high-speed active feeder. So it doesn't seem like it was a slow-moving bottom feeder. It seems like it was an active open-water shark, much more akin to great whites or makos or blue sharks, but still with those crushing teeth.
Yeah.
Which is a different combination, a combination we've not seen in sharks, fossil or living.
Yes, which brings me back to my question. What were you crushing with those teeth?
What were you doing?
I wonder if instead of hunting slow-moving shelled things on the bottom of the sea, if it was hunting fast-moving shelled things in the water column.
Absolutely. They suggested that this probably means it was going after things like ammonites and sea turtles that are open water, hard-shelled animals. So this might have been, today tiger sharks are specialized for going after sea turtles. This might have been a similar situation, but with instead of having chainsaw teeth, you made a nutcracker mouth.
Yeah. Well, and it raises the question, because today if you want to hunt something hard-shelled swimming around, it's sea turtles, because that's basically your only option. During the Cretaceous, there was a huge abundance of ammonites, shelled cephalopods. I wonder if a 10-meter-long crushing-toothed predator would not have food to eat. In a modern ocean, this is a type of predatory niche you could only do, potentially, back during the Mesozoic.
Absolutely. This also potentially gives insights into why it might have gone extinct when it did, because it went extinct before the end Cretaceous. So it wasn't the end of the Mesozoic that killed off this shark, but it might have been that that's around the time that we see blunt-toothed mosasaurs coming into their dominance and rise. And that competition with another open-water, fast-moving predator with teeth specialized for hard-shelled prey might have been too much competition.
Yes. Nothing makes me happier than seeing a marine predator group that was really, really successful throughout the Mesozoic and then trickled off shortly before the end of the Cretaceous. And I go, ah, the mosasaurs gotcha.
Yep. Which makes sense that is a group that also has fast-moving, blunt-toothed predators.
Yes, there are a bunch of mosasaurs. These are the big aquatic lizards with these rounded, pebble-shaped teeth for crushing, presumably, mollusk shells.
Yes. So we might now have a better insight into the way this shark lived and potentially its role in the ocean, as well as maybe its interaction with other predator groups. But it's also a unique shark. Like, we don't have an example like this.
Yeah.
So this is a first of a kind that we know of in the elasmobranch group.
That is extremely cool. And it's extremely interesting to think about how today there are, broadly speaking, 2 types of giant shark. Well, you can correct me if I'm wrong on this, but to my mind, filter feeders, like whale sharks and basking sharks, or macro predators, like great whites. I don't know what Greenland sharks eat. I guess they're also very big.
Yeah, well, they definitely are macro predators, but I think they also take a lot of scavenging because it's dead stuff ends up down there.
Sure.
But yeah, they have normal shark teeth for taking out big bites of big things.
Yeah. So to think of a similarly sized shark, a giant shark, eating something totally different with totally different teeth is very cool.
And it makes me also wonder, like, were your bite muscles different? Like, did you have just a complete... Because, like, sharks, they do have strong bites, but they don't need super strong bites to be able to do their job because their teeth are steak knives.
Right.
But if you are crushing, are your jaw... I don't know how different a, like, nurse shark's jaw muscle versus a great white's jaw muscles are. Would this one have a different face?
Yeah, and did you have a different hunting method? Does it require different techniques to catch ammonites?
Yes.
In the water column.
Cool.
Very cool. Well, continuing the trend of less and less vocal creatures, my bit of news to end us off is about eggs. But specifically, dinosaur eggs. More specifically, a new type of dinosaur egg.
Oh.
This is research by Ching He et al. In Cretaceous Research, and we will link to an article by Ding Rui in Sixth Tone. These are dinosaur eggs, which not a new thing. We have lots of fossils of dinosaur eggs.
Absolutely.
These come from the Liang Basin in Shandong, China. This is an area with lots of fossil deposits from the late Cretaceous, similar in age to your Tychodus sharks, including over a dozen different types of dinosaur eggs. So,
wow.
Eggs from all different groups of dinosaurs. This study specifically looks at 5 eggs that are here identified as belonging to a new O species. As we've discussed before, trace fossils in the fossil record tend to get their own species name. Episode 118. Footprints and trackways get their own species name that are often something ichneus or ichno something. Eggs also get their own species name, usually oo something. They're called oo species. OO species. In this case, the new species belongs to a known genus, Spherolithus. The species Spherolithus phaselis. They belong to a family called Spherolithidae, which are known across East Asia. This family of ancient egg types is known across the late Cretaceous in China, Japan, South Korea, Mongolia. It's thought that they might belong to relatives of hadrosaurs. So possibly hadrosaur, near hadrosaurs. These are the, quote, duck-billed dinosaurs and their cousins. These 5 eggs of this new oo species are spheroid, which is to say mostly round, like the Earth.
Yes.
They preserve fine details of the eggshell layers. So if you liked the layers of skin preserved, this is preserved layers of eggshell. The eggshells are between about 1.5 to 2.5 millimeters thick.
Ridiculous.
So very fine preservation. And it preserves multiple layers with different structures in them. And the structure of the shell, the microscopic structure that the shell is built of, is a unique combination of cone-shaped units, column-shaped units, and bush-like units.
Huh.
So these little microscopic building blocks, if I'm interpreting it correctly, in different shapes, in particular arrangements that are unique to this type of egg.
Yeah, that's cool.
The other thing that is unusual about these eggs, so the last 2 newses were about things that were exciting because of how well preserved they are. These eggs are exciting in part because they're not as well preserved as we might expect. All of the eggs are deformed in a way we don't see in dinosaur eggs typically. They are misshapen. They've been deformed, but they're still intact. They haven't been shattered like an egg. The article described it more like a ping pong ball that's been crushed or hit. The whole thing is still intact, but it's collapsed.
It's like dented.
Yes.
Weird.
Which is not what we would expect if this was a hard egg like birds and like dinosaur eggs that we know of.
Yes.
So the authors describe that this probably isn't a true hard-shelled egg, but based on the preserved structure of the eggshell, it also isn't a soft-shelled egg.
Yeah.
Today, among reptiles, we get this variety. And the sort of dichotomy that we talk about is either hard shell or soft shell.
Yes.
Hard shell being birds.
Yeah, like a chicken egg.
And soft shell being all the rest.
Yeah, which are kind of leathery, like almost... Plastic's not the right term, but...
No, but leathery is how I see them described a lot. For crocs and snakes and lizards and stuff. Those eggs, notably, tend not to fossilize.
Yes.
So there has been, we've talked about this on the podcast before, this question of how widespread was hard-shelled eggs across dinosaurs? Were the earliest dinosaurs hard-shelled egg layers? And if they weren't, how do we tell the difference between not finding eggs of those other dinosaurs because they just haven't happened to preserve, or not finding eggs because they're too soft to leave good fossils behind?
Yep.
These eggs suggest that there may have been more of a spectrum of diversity of eggshell types in dinosaurs.
Yeah.
In the article, one of the authors is quoted as describing this as a third option.
Yeah.
Which is, I think, a simplistic way to put it. It's more likely we are somewhere in between the two, on the spectrum between what we think of as the two options.
Yes, that like most things in nature, it's a gradient.
Yes.
With many steps along the way.
But this demonstrating that it isn't just two choices.
Mm-hmm.
There are other ways for these eggs to be.
Because, I know, turtles have shells, but it's a very, very thin shell.
Yeah.
From what I've seen, that it's not thick-shelled. So, yeah, this is weird, where you've got a mineralized structure, but seem to be deformable.
Right, it's soft-ish.
And I'm just trying to wrap my head around how would it even do that? Is it acting like chainmail or something? Or
and
is
that
it,
I don't know.
Man. Oh, that's...
Like a ping pong ball.
Like a ping pong ball.
It's made out of plastic.
It was made to bounce.
These were bouncy.
Yeah.
Those are just hadrosaurs on either side of the table tennis.
And it's like those videos you see of giraffes giving birth, is when they dropped it from 4 feet up, it just and bounced down the hill into the nest.
Bounced down the hill, right into the nest.
It was. Oh, what is it? Dude Perfect that does all those videos of them getting 1 in a million shots. It was a bunch of hadrosaurs gathered around as they trick-shotted their eggs.
Standing at the top of the hill, seeing who could get the egg
off
into
the boulder, down the hill, off the fern, into the nest.
That's a birdie. So, greater diversity of dinosaur egg styles, which is pretty cool to find.
That's so... Man, once again, dinosaurs must have been so much weirder than we can ever truly appreciate.
Yeah. Well, and I think it's always fair to look at any two states of being for dinosaur stuff and infer that there were also in-betweens.
Probably. Just because probably.
Yep.
Awesome. And once those dinosaur eggs hatched, they become very noisy dinosaurs.
Who talk to each other. As is directly evidenced in the fossil record by their TikTok reels that they left behind for us to find.
It's old. It would have been Vine.
Vine, yeah, they're vines. Yeah, you're right. They're vines.
They're old like us.
Well, hey, what a segue. We're going to wrap up the news, and after the break, we will be in our main episode discussion. We will be talking about language with our special guest, Dr. Bridget Alex. Join us.
Woo! Hello, Bridget.
Hello, David.
Welcome back. Thanks for returning to the podcast.
Thanks for having me.
Our listeners may remember that you were here for episode 177, where we talked about Neanderthals.
Which was a ton of fun.
Great discussion. Our listeners really enjoyed it. We really enjoyed it. So now we are returning to the realm of anthropology and paleoanthropology with a much requested episode about languages, which I am in particular very excited about. Before we get into that, if any of our listeners are unfamiliar with you, please introduce yourself.
Hi, listeners. I'm Dr. Bridget Alex. My research background focused on the spread of Homo sapiens and the extinction of Neanderthals, and trying to use various geochemical methods to understand where and when these different types of humans met. And I am now a popular science writer and editor for the magazine called Sapiens, as well as a lecturer at Harvard, where I teach courses in human evolution and science communication.
Excellent. And you get to teach courses about topics like Neanderthals and languages, as I understand it.
And anything that we think is unique to humans, anything that we think happened over the course of human evolution. Yeah.
Excellent. Well, if any of our listeners want to hear the extended versions of these discussions, they know where to enroll and which classes to take. Well, let's go ahead and get into this discussion about language. I'm sure we'll have a lot to say, ironically enough. If we could start with the simplest of the questions, Bridget, could you tell us briefly, what is language?
Well, before I say that, I'll say that it's something that gets anthropologists, and particularly people who study human evolution, very excited and sometimes fearful because we're always, trying to say what is unique about humans, when we compare ourselves to our closely related species, other primates, and particularly chimpanzees, what special adaptations evolved on the human branch. And just so many times when we think we came up with something special about humans, like, we invented agriculture. Ants did it too. Or, so many things that seemed unique to humans, using tools is another great example. And now we know so many species of animals use and make tools. There's just, a dwindling number of things we can claim as special. But language is special. Language is the form of communication that humans use. And it has some properties, or at least a combination of properties, that we don't see other animals using. And animals have very sophisticated forms of communication, but language, which perhaps the definition will be underwhelming, I would just define it as the form of communication that humans use. But it has this ensemble of properties that we don't see other animals using in their forms of communication. And so, of course, I can go into those properties, but just the, really exciting things about language, that you can say something that's never been said before. And if someone speaks the same language as you, they understand it. You can use language to communicate basically anything you can think. So if you're thinking about pancakes or politics, you can share that with people outside your own head.
Right. Yeah. I think that definition of language is the way that humans communicate. Right? Language is this. You're hearing it, you know it when you hear it or see it. I like that you said it's kind of an underwhelming definition. And I think that I like that short definition because it emphasizes both, number one, that it is very special to humans, and number two, that it is very difficult to define in some ways.
Yeah,
that it's that thing that we're doing in all of its many forms.
Yeah.
And it does seem to be, an evolved human skill.
Right.
Whatever human you find around the world can do it, unless, they have a language disorder. But people are born with the capacity for language.
Yeah.
Yes. Yeah.
So exploring deeper into this, how do we go about distinguishing language from other forms of communication that we see in other species?
Yeah. So again, you might find one of these properties in other animals, and we'll give examples. But when you're looking at human language, some of the essential features we see are what linguists would say it's open and generative, meaning what I already mentioned, you can say things that have never been said before. So, we don't have 100 things we can say and we're stuck with that amount. And, those are the words we use. We can invent new words. We can, words can change over time. So it's, open to change, and it does change. And it's open to statements that haven't been said or produced before. But also very constrained. There's what linguists would call semantics. So these sounds or signs, if you're using sign language, have specific meanings. We have, a set number of, in a given language, a set number of noises that we make. We combine those together in words, and everyone has speakers of that language have decided those are the words, and they have specific meanings that refer to real or abstract things. And then at the next level, another property of language is that it's hierarchical. So we've combined these sounds into set words, and then we have sentences. And you can't just put words in any order. There's some structure to them. And still with all that, you have the total freedom to say a sentence no one has said before.
Yeah. So it's structured and flexible at the same time.
Yes. And then also context dependent. Although words have these specific meanings, if I say something like, what's up? Depending on the context, whether I'm asking like literally what is above your head, or what are you, what's going on? What are you doing? How are you? Or just kind of greeting you, right?
Yeah. Well, whether it's friendly or ready to start a fight. What's up?
Right.
Yeah. So you put all those traits, that open and generative, that it's referential with meanings, that there's hierarchical structure, there's context, there's, you need a community of people who have all agreed upon these things or learned them together. That ensemble of properties is what makes human language unique.
I really appreciate the pointing out the, like, you can say something that's never been said, but also like describe a thing that's never been described before. Because that had never clicked in my head as how unique and special that is. But like, I can describe a thing I've never heard the words for, even if there are already words for it. But I can try to describe my interpretation experience of it using usually more words to try to get there. And then someone go, oh, you mean this? Okay, I didn't know there was a word for it.
Yes.
But that's what I was trying to describe.
Well,
and that's a cool ability.
And we do that a lot in education on the podcast, in classes, describing things that either we've never put in words before or our audience has never heard or seen in words before.
Yeah, I mean, just language is pretty awesome. I'm very glad that humans have it. I mean,
yeah. We're thrilled as podcasters that humans have language. This is very convenient.
Well, I've seen like joking posts online, but this point is still well made that like it's about as close as we can come to being psychic. The fact that I can put my thoughts into sounds, and those sounds can go into your ear and form hopefully similar thoughts in your head. Like that's pretty crazy.
Yeah.
Yeah, I was just last week, I rewatched the original Independence Day movie. And as anyone who's seen that movie knows, the aliens in that communicate with telekinesis and get into the president's head and show them what they're going to do. So, we don't have that. We do actually have to emit sounds or make signs or write symbols, but
yeah.
That's pretty close.
No, it's still telephone game technically.
Yes.
But that is extremely efficient, other than having to just use a set, number of noises that only can have those meanings.
Yes.
We can make up new meanings.
So when we're talking about language as something distinctive to humans, all these things that humans are able to do with their language, we are often comparing to other species, to other animals and their forms of communication. Are there forms of communication in other species that we typically look to? Are there things in other species that are kind of language or very close to language? What other examples are there that we tend to draw on?
Yeah, there are some expert communicators across the animal world. And I mean, I would also hypothesize that because so many different animals use senses that we don't prioritize, there's probably communication going on through different things than sound. And ways animals are communicating that we just don't even think to detect.
Like how we use body language along with language. There could be other components going on.
Yes, certainly, or vibrations they can feel maybe that they send to each other or things. But generally, if we're trying to understand human language, which is, predominantly speech-based, also with some also can be sign language and symbols, we are looking at other animals that, use sounds to communicate, use gestures to communicate. And so for different aspects of that, there's a lot of research. For instance, if you were interested in the hierarchical structure, the syntax, you might look to birds, right? There are very complex bird songs that have stanzas and have to go in a very specific order of what noises you make when, and that has important implications for reproductive success. But of course, birds are quite distantly related to humans. So if you really want to track what sort of components our language evolved from, of course, you want to look to primates. And across primates, broadly, there are some great communicators. Primates are, many species of primates are very social. So, of course, there would be pressures for them to communicate well. One type of monkey that's well studied are called vervet monkeys, who live across mostly in Eastern and Southern Africa. Although some got to the Caribbean, much later, a few hundred years ago, and are drinking cocktails at resorts.
Yep.
But the, vervets in Africa, since about the 1980s, researchers have been studying them because they've noticed, particularly in this area, that they make these very specific alarm calls, and we can link to some of them in your show notes. But it's basically one vervet monkey will spot a particular type of predator and make the leopard call, or the eagle call, or the snake call. And the rest of the monkeys in that group will react accordingly. If it's a snake call, they look down, like, where's the snake? If it's an eagle call, they look up to the sky. So there are these if you're interested in, referential aspect of language, here is another distantly related primate species. We probably share ancestors with them some 20, 25 million years ago, but, it exists among primates. And then, moving much, much closer to us in evolutionary history, we can look to our closest relatives, chimpanzees, chimps and bonobos. And they, are also great communicators. They live in very complex social groups. They have vocalizations or calls that things like grunts and hoots and barks and alarm calls, they're have been challenging for researchers to study. They seem a little more ambiguous, but they are context dependent. There are, ones they make when they're excited. There's ones that they make when they're angry. There's subtleties to them in terms of, oh, I make this type of call when I'm feeding, but when I really like the food, I alter it in this way. There was a lot of uncertainty whether they could control these or if they're just involuntary. Like every time I see a delicious food, I have to make this call. I can't stop it. But it does seem like they have some control over it. They can look about who's around, who do I want to hear this call, who do I want to communicate with. But the other thing that people have noticed a lot with chimps and bonobos is more so than their calls, they have many gestures that they communicate with. And it's in social contexts, things like two chimps will raise their arms and touch in a sort of above the head high five. They will shake branches. They do all sorts of gestures. About 70 of them have been observed in the wild that are for communication. And maybe we don't understand them all, but chimps seem to. And it's not clear if that's fixed and the meaning of that can never change, or if chimp communities can change it over time.
Yeah.
And that has led a lot of people to think, okay, maybe the origins of human language might be a combination of calls and gestures if we're looking to what chimps do, at least.
Yeah, it's not surprising that we would find very similar features to our language in our close cousins.
Yeah.
And then the other big area to mention in terms of looking at other animals as very famous or infamous set of experiments where they've taught apes sign language or they've taught apes human language. So these are called the ape language studies, started about the late 60s or 70s, with some famous apes like Nim Chimpsky, named to annoy Noam Chomsky.
Sure.
And Washoe, who is also a chimpanzee, Coco the gorilla, Chantak the orangutan. These four individuals successfully learned a few hundred words of American Sign Language. But the all-star, absolute best trained ape in human language is named Kanzi. And Kanzi is a bonobo. He's 43 years old. I check this every year to make sure he's still alive. and I checked today. Yeah.
Okay, good.
He lives in Iowa, and in a sanctuary, has some offspring. And what happened with Kanzi is the researchers were actually trying to train his mother, and he was just a little infant in the same cage, and they really didn't have much success with her. But it turns out, like, anyone who's ever been around an infant or toddler, Kanzi just sort of naturally picked it up, and suggesting that just like with humans, where there seems to be this window where it's quite easy to learn the language that's around you while you're a little baby, compared to when it's incredibly difficult as an adult.
Oh, yeah.
That Kanzi just picked up a lot. And in the end, they trained Kanzi with this board called lexigram. So it's pictures that are symbols, and he points to the different symbols or lexicograms, and those are words. So Kanzi uses this big board of pictures to communicate, and knows about 400 of those words through that, and then also understands about 1,000 spoken English words.
Wow.
And also does some sign language too.
Yeah.
So perhaps arguably a capacity for language in this bonobo.
Arguably, but so Kanzi understands, they say, about 1,000 words in English, but I know a lot more. And I'm not famous,
Yeah.
And there's about 170,000 words in the Oxford English Dictionary. So 1,000 isn't that much. But in the most, systematic studies with Kanzi, when he was about, I think, 8 years old, they compared him to a 2-year-old child. And they both did about the same in terms of understanding things. And what was very cool about it is they showed, both the 2-year-old human child and the 8-year-old Kanzi understood that order matters. So they knew a sentence like "put the hat on the ball" was different than "put the ball on the hat."
Yeah.
And you can, we could link to some YouTube videos of it. It's some of the sentences. It's like, "pour the Perrier in the bowl." And Kanzi knows Perrier. Or, "put the pine needles in the refrigerator." And Kanzi will do it. He'll understand the instructions. Both the child and Kanzi completed it just over 50% of the time. But that basically means they understood. But, telling a 2-year-old what to do doesn't always work out, even if they understand, right?
Yeah.
Right.
Whether or not they decide to follow the directions is another whole gamble.
So we have a lot of things, some of the components of language.
Yeah, we have the vervet monkeys. That feels like that's a pretty solid. You at least have words for things, or defined terms, I guess.
Well, and it sounds like Kanzi understands at least some measure of syntax. We have sort of these pieces of language that we can observe in other species.
And with the things like vervet monkeys, or bird songs, for instance, it shows that in very different lineages, elements of human language can evolve. They could be evolving for different reasons.
Yes.
There's different selective pressures that would say, being able to sing a song with syntax is important for your survival and reproduction, or knowing that when I make this call, you better run from a snake is important for your survival.
Run in the right direction.
And then when we look at chimps, some of that stuff might actually be the stock we started with, right? Traits that might have been in place with the common ancestor.
Yeah. So you mentioned earlier this fascinating phenomenon that we've alluded to on the podcast before, that there used to be, right, hundreds of years ago, this long list of stuff that makes humans different from all of the beasts and such, and that list has just been shrinking over time as we've observed tool use and agriculture, right? Farming sort of techniques. Do you think, and this is speculating, do you think language will ever make it off that list? Are we going
Dethroned.
to find a population of chimps or like bees or something that is technically,
or like dolphins, that get to the point where we finally understand them enough to really realize what's going on?
Well, I would love it if that does happen. And I have a very humble opinion of humans compared to other animals, and very, very much esteem for other animals and their ability to solve problems in their own worlds and evolve traits like complex communication that allow them to do so. I mean, if we define languages the way humans communicate, we can keep it as ours.
Right. And no one else gets to do it.
I'm wondering if we'll have to. It's just getting more nitpicky about which things they don't do. Is it, well, you don't have curses yet, so you're not communicating like we do.
That's probably what we do to keep it to ourselves. Yeah.
You're not quoting movies, so it doesn't count.
Nope,
this is a human thing. Well, zeroing in on human language in particular, as that is sort of the focus of the discussion, I'll start with, whenever we talk about behaviors and groups of life, we like to start with a sense of diversity of that thing. So I'll start with a very simple question with what I know is a very complex answer. Among humans, how many languages are there?
The count you'll always see is about 7,000, a little more than 7,000 used today. And that comes from UNESCO and a big project they have called the World Atlas of Languages, where they list all languages that are known and traits of them. You can go to the website. It's very fun to explore.
Cool.
And in the World Atlas of Languages, they say about 7,000 are still in use. Their atlas, because I just looked it up, 8,324 languages. So some of those are known from history, historical records, or, someone spoke them 50 years ago, but no one speaks them now. So ones that have been lost in recent times. Yeah. And of those, also UNESCO says that about 50 to 90% are in danger of being lost, in the coming decades, centuries, because there's not, enough speakers to pass it on and be fluent in it, and a community of speakers.
Yeah. And getting replaced by other languages as they come in.
Yeah, this is very similar to when we talk about populations of species that will sort of become restricted to one particular place, one particular island or something like that. And then if the conditions that sustain that species are no longer there, it can disappear. The same thing can happen with languages and the communities that speak them.
And you need a population. Because a language doesn't exist on its own very well.
Yes, it is an emergent property of human community.
Yeah.
Yes, unless it's a language that is also written, and people have written abundant text of it. So, we do have languages that no one speaks today, like ancient Hittite or Greek, that, we just know from the texts.
So across all of these languages, so we've got all these different distinct languages in different parts of the world. We've mentioned sign language a couple times here, which of course counts as language, even though we tend to think of language as a verbal thing. What are the major features that we tend to see that are common, that unite all of these languages? And what of those features are variable? Which ones tend to be different between different languages?
Yeah, and this is another reason why, aside from just the kind of ethical or moral reasons you would want to keep languages alive for, perpetuating culture, diverse cultures. If you're interested in human cognition and language, you need all the languages in order to answer that question, because inevitably you'll say, okay, all human languages have this, and then you'll learn about this language that you had never heard of before, that it turns out they don't have that thing, or they don't do that thing.
All the languages I speak have this feature.
Yeah.
So the diversity of languages is essential for studying the evolution and origin of language, of course. And all the languages we know have a limited set of signs or sounds that are combined in meaningful ways to then be able to say infinite things. And so, this balance of finite symbols that we use, that we packaged together according to some rules to create infinite meaning. But there's a lot of variation, and all of them kind of use vowels and consonants, but the number of consonants can vary wildly from I saw the lowest count was around 6, highest around 120 in a given
Wow.
language. There's languages with clicks and whistles, and there's tonal languages where for someone who's not a speaker of the language, they'll struggle a lot because subtle different tones in what might seem like the same sound have meaningful differences.
Yeah. When I studied Mandarin Chinese in college, there was like multiple entire lessons just about getting the tones right, because me and the whole class of English speakers, this was a literal foreign concept to us that really took some getting used to.
Yeah, and I remember different Slavic languages I've learned, like spending days being like ch or ch, ch or ch. And to me, it's like, it's the same.
Yeah. To where for us, we might be like, well, that could change with an accent, if you're from one state or another.
Right.
And for them, it's like, no, those are different. We have different symbols to denote.
I had that when I had some friends in college who were trying to teach me the basics of Korean. And it was like, we have a P sound and a B sound, and then there's this in-between sound. And I went, what? In between? It's this third version of it that I had a really hard time getting the hang of.
Yeah. If you haven't grown up with it, it's a very abstract and fantastical idea.
And speaking of growing up, that's another feature that all languages seem to share is if you grow up in a given language, you'll probably learn it, unless you have some sort of language learning disability. Children growing up in a given language learn that language. They don't, arbitrarily learn a different language spoken around the world, and they do it quite easily. And all languages so far, another feature is their sentences seem to contain a subject, object, and verb, but the order of that can vary, and it does vary.
Yeah. One of my favorite things about linguistics, and the thing that used to just really, I would just read about this forever, and it's my favorite thing about linguistics, is looking at the ways that similar pieces are different across languages.
Yeah.
The sounds that this language uses, the sentence structure, the way that idioms or names or places are structured or placed within the sentence. It's all the familiar pieces, but organized differently, utilized differently. And it's a really comparative linguistics for me is as fascinating as comparative anatomy.
Yeah. Yep.
All the same pieces doing something different for similar functions. And it's really cool to look into.
Yeah. And how much you load into one word versus spread out across several words.
Unfortunately, this is not an episode about comparative linguistics. If it was, we would be here for twice as long.
Yes.
Maybe some other episode in the future. Although I do want to point out that we study languages in a very similar way as we study the relationships between species, between different organisms. Languages aren't just... they don't appear out of nowhere. Yeah. They're related to each other.
And they're built off of and from one another.
Bridget, can you comment or talk a little bit about historical linguistics, the way that we understand the relationships between languages?
Yeah, this is a super fascinating area. And I would say linguistics or linguistic anthropology is already a small field, but historical linguistics is an even smaller. So it's, there's not that many people worldwide who study this, and they probably all know each other and argue with each other all the time. But using methods borrowed from evolutionary biology, so phylogenetics, building evolutionary trees based on shared traits or DNA mutations, as we do today. Historical linguists try to reconstruct the relationships between languages, because languages are related to each other in a nested, branching fashion, just like species. And they do descend from common shared languages. There is some debate if all languages on Earth ultimately derive from one proto-language, or if, in different parts of the world, at some part in human evolution, we had these proto-languages, and they evolved into the major language families we see today. So clearly we can see more recently in time, though, you can take something like the Romance languages, Spanish, French, Romanian, Portuguese, Italian, and you hear them and they must be closely related to each other in terms of structure, in terms of words that they use, in terms of sounds.
Right. They have similar features the same way that all mammals have similar features. It's descended from common ancestry.
There's more overlap in the parts that are being used.
And and we have texts for this part of history. So they do indeed descend from a common language, but that language descends from an even, earlier ancestral language, which is Indo-European. So the Indo-European language family is even broader, includes the Romance languages, includes Germanic languages, English, as well as Farsi, Hindi, pretty widespread, in fact, spoken by about 3 billion people today. I mean, much of that is from the last few hundred years of colonization, imposing English and Spanish and Portuguese on the world. But just even in the native lands of these languages, it's a pretty widespread language family. And actually, a very big topic of debate is, where and when exactly was the Proto-Indo-European language? We can do this with any of the major languages families on Earth, like Austronesian languages, which are spoke across the Pacific and islands of Southeast Asia and Madagascar. You could take any of these major language families and really try to, find it's challenging because you have to find traits to compare across them. And unlike at least mammal evolution, there can be a lot of horizontal transmission, where if your neighbors speak a totally different language, but you borrow some words from them, or they, conquer you and force some words upon you, there can be a lot of exchange between languages. And also the rate of change for languages is not so predictable, depending on how many speakers you have, how spread out you are, how, if you're have a bunch of speakers of a given language, but they get kind of isolated, how soon will this dialect not be incomprehensible to the people over the mountain? So all those things pose challenges, but, then again, people who study microbe evolution have to deal with horizontal transmission all the time. And, there can be computational methods and approaches to kind of deal with this. And then, estimate when these ancestral languages existed and where the speakers might have been based on archaeological evidence and things like that.
I'm immensely tickled comparing it to horizontal gene transfer.
Oh, yeah.
Because that was going to be the question I was going to ask about when languages get mixed, because of populations coming together. Because my family's from Louisiana, so Creole mixture of the French language with English has always been fascinating to me. Thinking of it as horizontal gene transfer makes me so happy.
And it makes linguistic study, ancestral linguistics and historical linguistics, complicated in ways that I think microbes are a great comparison to, because we've talked about that on the podcast, where we'll talk about examining the evolutionary path of mammals and reptiles and birds and all this stuff. And then microbes come up and we just kind of throw our hands in the air and go, well, they're kind of doing whatever they want. And who knows? And language sometimes can feel a little bit like that. So I'm impressed and delighted that there are people able to sort that out, that there is a realm of science for deducing those relationships.
Yeah, one cool study that came out last summer was they published a database where, particularly focusing on Indo-European languages, they made a database of cognates. So these are words that they think are similar between all these languages, like English and Farsi and Spanish, because they come from a common origin. And they looked at words that are just kind of very basic universal concepts that you would think, yeah, everyone needs this word. Things like water, to, foot, black. And then, compared it across like I think about 100 Indo-European languages and made this nice database of like, indeed, these words are similar because they're shared from common ancestors. Let's just use these words for building our trees. So that was, one approach that can be taken, and, probably the most straightforward way to go about this, if you have such a good database.
Yeah. Looking for the shared features that can reliably be used to compare.
Well, and like you mentioned earlier, Bridget, we do have, extending the comparison with studying biological evolution, we do have a sort of fossil record in the form of written texts and things. And nowadays, of course, we have recordings, which I'm sure moving forward into the future anthropologists will be extremely thankful for. We do have some records of languages the way they were in the past, or languages that are no longer around, which serves as insights into the past, similar to the way that we use the fossil record.
Yes, definitely. And in the case of Indo-European, that's a language like ancient Hittite. No one speaks it today. There's texts from ancient Anatolia, and they can be, they're dated. So yeah, we can actually try and calibrate those branches in the evolutionary tree from what's the analogous thing to fossils, written texts that are dated.
Yeah. It's very funny because one of the common phrases that I remember hearing in my classes, and I've seen come up a lot in discussions about how we understand animal and plant evolution, life evolution, is the fossils don't come with labels and dates on them. We can't pick up a bone and it says horse from 8 million years ago. Some of those texts do come with labels and dates on them, which is very convenient.
Yes. Yeah, and it's at least in the Mesopotamia region, the earliest texts are related to administration. So they're pretty much all dated.
Yeah.
When you get into historical linguistics, it's really the area where genes, culture, and culture meaning archaeological artifacts, and language converge. And sometimes those three records agree and sometimes they disagree. So you could find an archaeological site, where there's certain pottery left, and there's human remains. You can get DNA out of them, and then you might wonder, okay, what language did they speak? How does, is there a wave of people speaking this particular language coming through over time? So a lot can come out of historical linguistics, trying to see when these different languages split, when they arose, and does that actually map into any changes we see in the archaeological record or the genetic record of humans.
Well, and I'd assume you'd run into the same problems that we run into with fossils of, like, if we find this one odd fossil in an area, trying to determine how much of that is this a unique population or an odd individual, like with language, that was this a change in the language, or was this a regional dialect that popped up and then was only ever in that region, never made it out of, that area. So it's not actually a lasting change in the overall language. But if you only have like one book from that area, you might not be able to determine it all.
Yeah, and then although it is more difficult after toddlerhood, we can learn more than one language.
Yes,
right.
Certainly, in some ancient societies, we're very multilingual, and you don't have to stick to the same language your whole life.
Well, and like we have a bunch of words in our language, like here in the U.S., that are used that are other languages. Brands and names and terms for stuff.
That's that horizontal transfer.
Yeah, exactly that. But that if you asked people, they wouldn't know what language it is. Like, does everyone realize how many French words they're using and how many Japanese words they're using on a day-to-day? Or are they just like, no, that's just the name of that thing? Well, but it came from this other place.
Well, let's take a short break here, and then when we come back, we will explore even deeper into the story of language, back into the paleo realm, and look into the origins and evolution of language, and start talking about some of our early humans, hominin relatives, and see what there is to say about that. Stay tuned. We'll be right back. So, Bridget, to get us started on our discussion of language origins and evolution, I'd like to start by asking, how do we study the origins and evolution of language? What tools do we use to do that?
Well, I mentioned at the beginning of the show a topic some anthropologists or people who study human evolution avoid and fear because people say, oh, language doesn't fossilize. Well, plenty of things we're interested in don't directly fossilize, and we
Yeah.
go about studying them. And it's such an important aspect of human behavior and society today that, it would be uh, a huge disservice to not study the evolution of language. And there's a kind of famous, I thought it was apocryphal, but I think it might actually be true, incident that in 1861, the Linguistic Society of Paris put a ban or moratorium on any speculations on the origins of language because they felt like people were just throwing out so many wild ideas that could not be tested scientifically. And if we can't form a hypothesis and test it through the scientific method, we should not be discussing this within science, right?
Yes.
And it felt like this is something, like metaphysics, that origins of language is not something we can study. But in fact, it is. There are lines of evidence that we can at least say, what are the different adaptations that humans need to have language as we know it? And do those adaptations leave some sort of trace in fossils, in genes, or in artifacts left behind by humans? And fortunately, language requires a lot of things from a human. You need the cognitive abilities to think what you want to say and tell your body to, if you're using a speech-based language, produce the sound, which is going to involve controlling your diaphragm and your vocal cords and your tongue and your mouth and probably lots of little muscles I don't care to learn the names of. And you're also cognitively, you need theory of mind. You need to know that if you say something, someone else will understand it and respond appropriately. You're going to need, again, if it's a speech-based language, you're going to need the auditory apparatus, the ears, and everything that's connecting your ears to your brain to receive it. And then you need to understand it too. So there's a lot going on. You're going to have symbolic thought. So knowing that an arbitrary symbol can mean a specific thing. And so all of these things, might leave traces in fossils, artifacts, or DNA. Some particular ways that people have gone about it, since I am primarily an archaeologist and biological anthropologist, I've like the archaeological record for this question. So when you start to see things that human ancestors were making that are just absolutely symbolic, like widespread making of beads or personal ornaments, painting a figurine, making figurines, painting caves, things that we might call art. Clearly, people understand symbolism, so that piece of the puzzle is in mind. If you have a bunch of people making beads, which we see as early as 100,000 years ago in the archaeological record, and they're making them out of specific types of beads, there must be some shared understanding of meaning that, we make beads this way because we're part of this community. It means something to us, this, random shell that I'm piercing with a hole and I'm doing it hundreds and hundreds of times, or making beads out of teeth, or carving them out of ivory, things like that. So, when you start to see symbolic artifacts, there's one piece of it, but that's pretty late in the story of human evolution. Another way you could go is looking at fossils. Any of those sort of things that are needed to produce speech might require changes in your skeletal anatomy. And people have gone about kind of looking at things like within the inside of skulls, the areas that we know are important for language, sometimes kind of imprint on the inside of brains. When do we see growth of those areas? Another way people have kind of looked at it was, for instance, there's a hole in the bottom of your skull called the hypoglossal canal, and through this a nerve goes which controls the motor functions of your tongue. And presumably, when you need a lot of fine tongue control, would be when speech became important in human evolution. So they've like looked at a bunch of fossils, measured the size of this hole, and find that it increases, at a certain time in human evolution. But
Mm-hmm.
I'll also point out that creatures like gibbons, this hole's pretty big, and gibbons don't have language as we do, but they sing a lot actually.
Yes.
So and it's very important in gibbon social life to sing for your mate, and to bond with your mate that way. So there could, maybe any kind of increase in the hypoglossal canal was related to humans singing more at some point in our evolution, necessarily than having language with specific referential meaning and syntax and blah, blah, blah.
Yeah, a lot of these are similar to things we've talked about before on the podcast, evidences we look at to tell communicative abilities, not only in humans, but in other ancient animals.
Yes.
Where we'll look at the structure of the ear, the structure of the nose or the mouth to get a sense of what sort of sounds was this species capable of making, what sort of sounds was it capable of hearing. A lot of that same stuff applies to human communication.
Yes.
Yeah, so you'll definitely find those studies in human evolution. Yeah, what sounds could the human ear detect? What pitch frequencies could we produce and receive? Those kind of things. And then the other line of evidence is genetic. And of course, people have scoured the genome for any genes related to language production or comprehension. And actually, like the earliest one ever detected is still seems to be the most compelling and interesting to this story of language evolution. This is a gene people might have even heard of. It's so famous, called FOXP2.
Sure. I've heard of that one.
I don't know if you're joking or not, but have you?
No, I have actually heard of that one.
Okay.
I've heard the name, but
I couldn't
don't
tell you
remember.
much about it,
Yeah.
but I have heard of FOXP2. It's filed away with Sonic Hedgehog and a couple of those other ones.
Yeah. So it's an important one across mammals. Does a variety of things. It's a transcription factor, so it like dials up or dials down a gene, but it very much does. It's highly conserved, meaning it barely ever changes across. When you compare a mouse to a human, say, there's very few changes between them, but 2 of those changes happened since humans split with chimpanzees. And there's only one other difference between us and mice. So across about 70 million years of evolution, within the last 8 million years since we split with chimpanzees, there's been 2 changes to this gene. And from studies where people have mutated variant of FOXP2, they have trouble with many aspects of language, control of mouth muscles, comprehension of grammar, fine facial movements. So it seems to be important in both the production and understanding of language. And, we know humans have a unique variant of it compared to chimpanzees and, most other mammals. Neanderthals also have this variant. So that gives us some sense of at least one gene that we know is essential for human language that has changed since we split from chimpanzees. The Neanderthals also have those same changes that Homo sapiens have.
Yeah.
Okay.
And you were talking about symbolism and beads and such like that, which we also talked a bunch about in regards to Neanderthals back in episode 177.
Yes. And Neanderthals don't do it as much as Homo sapiens, but I think language might be kind of the same thing, that, maybe Neanderthals didn't have all of the elements that we have in language that Homo sapiens use today. Maybe their language was different and maybe more simple, but perhaps they had the capacity to have just as complex language as us, but they didn't have any reason to, if there was smaller population size, just like how, technology gets more advanced when you have more people around, more innovation over time, it ramps up and it ramps up. Languages could also become more complex if there's pressures for them to, or more simple if there's, no reason to be complex. So Perhaps Neanderthals had the same capacity for language, but it was different. We know Homo sapiens and Neanderthals met and mated and possibly communicated during that process.
Yeah.
Yeah. It would at least make sense that there was some method of communication that the two groups shared.
I think I will give listeners one answer with absolute confidence that I can say. So I do, teach about origins of language in every kind of overview of human evolution course that I teach. And it's always a big question, like, where do I put it in? Because it's so wildly debated when since humans split from chimpanzees over 7 million years ago, when in that time period did our ancestors evolve language like we have it now? And it's, so wildly debated. I, could probably put it in any time in a course that covers human evolution. But I will say with confidence, it happened sometime between 8 million years ago when we diverged from chimpanzees and 300,000 years ago when Homo sapiens like us exist, because we know
somewhere in that window.
Yes.
So very rarely will a scientist tell you something with absolute confidence. I will tell you it happened with absolute confidence during that window.
So we were talking about Neanderthals, and of course Neanderthals nicely fall after the minimum bound of that window that you just listed. Do we have any sense or any suspicion about the language capabilities of course, early humans, right? Homo sapiens, which shows up around that 300,000 years, but our relatives or other ancestors?
My view on it is that the components you need for human language are so complex that they would have been in place before we see fully modern humans around 300,000 years ago, probably been in place about 700,000 years ago when Neanderthals and modern humans last share ancestors. So the shared ancestor of Neanderthals and Homo sapiens. I would think most of the components would have to be in place by then, just for how complicated language is. And those little clues we have, like symbolic behavior and various changes of the skeleton that would be conducive to producing language, and the FOXP2 gene and other genetic markers for existing in Neanderthals and Homo sapiens. I think safe to assume those things were in place in the common ancestor of Neanderthals and Homo sapiens.
Mm-hmm.
But other scholars who have all the same evidence as me would say Neanderthals did not have language, or they had a sort of language that didn't have all the components that Homo sapiens language has. Maybe, they could communicate, but it was more like it didn't have syntax, the kind of typical image of cave person language where you just say the words, but they could be in any order or something like that.
Right.
Yeah.
So we have a sense of how language kind of came to be and by which point in human evolution we can see, sort of reasonably infer, we have proper language like we do today. When it comes to other hominins, when it comes to Neanderthals and, earlier, Homo erectus and Australopithecus and stuff like that, it's very difficult to say anything for certain. In your mind, what would be like the piece of evidence that you'd want to find or that would be very convincing to show that, Australopithecus or Neanderthals had some language capability?
The Paleo Rosetta Stone.
Yes, exactly. Chiseled into a rock.
I think if pushing back symbolic thought known from items that they made that just must be symbolic because you wouldn't make them otherwise, and you would need people to understand why you're making them. Pushing that back, if you found some Australopithecus who were making beads like wild in a widespread and prolonged way, I would think, wow, they must really have complex communication. Maybe they even had language as we know it.
Yeah,
that makes sense. Beads or art, other forms of art like cave art, stuff like that.
Well, it feels like that's also very strong evidence for potential language, because not only does it show the capacity for thought for forming meanings and everything, but also it would be very helpful if you had a language to communicate the abstract and symbolic meaning behind the things, and to teach them and pass them on. Like, this is a potentially a more difficult thing to communicate without language, or would at least be easier with language.
Yeah, I guess we know that you don't need to have human-like language to teach another individual how to use a tool, because chimps do it and birds do it. But I would imagine that the more complex the tool gets and the more specific the creation mechanisms become, the more likely it would seem that there might be some sort of language helping to teach those things,
especially if it's not a practical thing. That's
if it is an artistic, symbolic
exactly
thing.
This isn't going to help you eat. It represents something.
But and these hypothetical beads we're finding 2 billion years ago or something.
Right.
Cute. I mean, the earliest beads are about 100,000 years, so we're adding a couple million on. But if you were to find that and really wanted to make a convincing case, you would want there to be diversity of them, so that perhaps different beads would have to mean different things. You could see that kind of evidence of some Australopiths having beads and say, oh, well, they just decided it was sexy. They saw one putting them on and they all wanted to put them on. They didn't have to. They didn't have to talk to do that, or something like
joy.
that.
Yes.
Yeah.
Well, if someone ever discovers some bead-like structures from, the Laetoli beds or some Australopithecus time, it'll be the most argued about discovery for that decade, I'm sure.
Yeah.
But listeners, to be clear, this has not been found.
No, this is all speculative. This is hypothesizing about what sort of evidence is useful in determining these sorts of things.
Artifact wish list.
For now, Homo sapiens, it seems, claim exclusivity in modern language. Maybe some of our cousins like Neanderthals were doing something similar. But like you said earlier, even though we do have some evidences we can go on from genetics or the fossil record, that only gets us so far, and there's only so much to use there, and it makes it very difficult.
That feels like the kind of category that we hit with dinosaurs a lot of time of, I'd be surprised if they didn't have something, but the evidence is not there to actually back up that feeling.
Much like we've said with dinosaurs, did they do silly dances and sing songs? Probably. Did early humans and Neanderthals and Homo erectus do silly dances and sing songs? Probably. It's just very hard to find direct evidence for that.
You can find a book called The Singing Neanderthals that argues that there's this very musical proto-language that Neanderthals had, but they didn't have fully modern human language, but they were singing quite a bit.
Interesting.
They're like that one planet from the Marvels.
From the Marvels
that only sing. It's just a musical species.
This is the paleo documentary that I want, which is about early humans and our relatives, and it's a musical. It's a musical documentary. Yes. Is there anything else you want to mention about language origins and evolution before I move on to my next question?
Well, the other big area of language origins and evolution are hypotheses for how, why, what was the selection pressure to get this language that we have. And now, most scholars of language evolution of language would be how languages change over time.
Yes.
Language evolution would be, the OG language. So most scholars today would say it's multimodal, like there was different selection pressures for different aspects of it, and they came together in the right time and place when it was beneficial to have this complex form of communication that we have. But over time, there's been, those different components can each have their own hypotheses. So some of the fun things that might have selected for aspects of language, like all the different sounds we can make, for instance. Perhaps singing was important for that in courtship displays or so. Another hypothesis has been called putting down the baby hypothesis. So this is the idea that as human ancestors were walking on two legs, and they have these infants that are born a bit incapable relative. Chimpanzee infants can cling on to their mothers. They can grasp already, but you have to hold human infants. But while you're a forager, you on two legs, you're going to have to put down the baby while you're, picking foods, digging up tubers, whatever. But you'd still want to comfort that baby. So being able to sing, being able to, make noises that lets the baby know caregivers are nearby, even while it's put down, was some selection for complex vocalizations, people have argued. So that's the putting down the baby hypothesis.
Nice.
Another fun one is called social grooming. And from this derives from the observation that our primates who live in social groups have to groom each other a lot. It's a way to secure friendships and good relations. You go up to another primate and you pick parasites off of the fur and clean out sticks and leaves and things. And it's also kind of like a massage. It's very important for your social relations if you're a chimpanzee, for instance.
Yes.
And as human ancestors, social groups got bigger and bigger, they argue it would take all day to physically groom.
to groom the whole village.
Yeah, to
Exactly.
maintain all your relationships.
Yeah. But with language, you can groom several others at once.
Right. So somehow this language was so, again, singing might come into here, that something you could do with your language was a way to shore up these social bonds the way that grooming was before. Another component or idea that comes up is gossip and the importance of gossip in language. And I think a lot of what we talk about is gossip, in fact, particularly for who's abiding by group norms, and who's carrying their weight and who is, slacking on their group obligations. If you work in an office, who left the copy machine with no paper, who didn't clean the coffee machine when it said clean the coffee machine. That kind of thing is what we tend to talk about a lot. So a problem of, human groups and living together in groups that got larger and larger is knowing that everyone was contributing. So, there's pressure to have complex form of communication so that you can tell on each other. Gossip.
And it feels like that's kind of the other side of the coin from the, building relationships is also keeping track of who you're not friends with, or even who your friend's not friends with. You know? If that other member took food from the person you're friends with, it might be important for them to say, "Hey, don't hang out with them."
Right, we
will stop being friends if you keep being friends with them.
Yes, keeping each other accountable for the rules of this growing culture and society. That makes sense.
Yeah, reputation tracking.
Just human evolution has just been one grand, long, Victorian, Bridgerton style gossiping and tracking relationships and reputations.
Hear?
Yes, exactly.
Another area it seems to be important to have complex communication is that, humans probably starting around 2 million years ago become foragers or hunter-gatherers, meaning they go out, kill or collect animals and plants and bring them back to some sort of home base and share them among the group. And, other animals don't really do that, or at least not our closest primates. They're more eaten on the go as they move around. Anyways, so foraging is a pretty complicated endeavor, particularly hunting, and that you might need some complex communication to pull that off. And this is where, in my mind's eye, when I imagine language emerging, I picture this pack of human ancestors, maybe around Homo erectus times, 1.5 million years ago or so, where one of them sees a gazelle-like creature running and they kind of pantomime and act it out for the group, acting like the gazelle, and then point in the direction they saw it run and act out hunting, and then beckon everyone and they go along. And make certain calls that they know that animal makes. So a combination of pantomime and gesture, onomatopoeia, words that sound like what they are from all that. Plus, if you're developing your, singing abilities to soothe babies at the same time and, evolving symbolic acts and a desire to gossip about people. All of these things kind of come together for this, multimodal cause of language as we know it.
Yeah, that makes me think of bees.
Yeah.
Which some bees very famously do their little dances to tell the other bees in the hive where to find these flowers. That is obviously an important driver for communication. If I went out hunting and I found this great grove of whatever plants we want, or a grove of gazelles, I guess, and then you have to come back and you have to communicate that somehow. You have to tell everybody, this is where we're going to go. Come with me. These are the directions.
Yeah.
This is what I found.
Or I need help, to get this thing because it's going to take more than one of us.
And you have to say, well, how many gazelles are there? And now you have to invent numbers.
Mm-hmm.
It's like, well, okay, now we have to figure out a way to communicate that.
Yeah.
I think it's very interesting that we often, and this is a very tempting thing to do, is when looking at the development of language, which is something so distinct and unique and special to humans, to link it to other things that are distinct and special to humans. To say, maybe the development of language was related to these more and more complex societies, or these complex behaviors, or our unusual styles of parental care, the fact that our babies come out just fully useless and we have to do everything to take care of them. Tool use, of course, as our tools become more complex, it makes a lot of sense to suspect that a lot of these things were evolving in tandem and influencing each other.
Yes, absolutely. This is a question that I'm sure there's not actually the ability to answer, but
we'll speculate wildly.
Yeah, just for are there leanings one way or the other as to, was there a human language, or could it have been developing separately?
Well, there's definitely a number of thought-provoking articles that try to hypothesize what would a proto-language look like before we have language with all the properties. Did syntax come first, and what would that look like if that were the case? Did referential meaning come first, and you would just, string together words in any order to try to communicate? And so that's, the way that at least Hollywood has depicted Paleolithic people speaking, like cave here, meat now, or MEAT, meat, fire, good.
Yes.
But, there's no evidence that was the case, that referential meaning came first and syntax came later. But you could, imagine what language would look like in any of these cases if we took those different properties and said, what would it be like without one or the other? So people have imagined what different proto-languages could have been if it was very sing-songy, a lot of and had kind of more ambiguous meanings, if there was more gestures at the beginning, more onomatopoeia words that sound like what they mean.
And you mentioned earlier this question of whether human language is what we would call monophyletic, whether it has one origin and all human languages are derived from that first language, or if it's something that developed independently from these early components. And it sounds like from what you said before, there's been some discussion about that.
Very well, if all these, different components evolved for different reasons and were useful for other things, then human ancestors spread to different parts of the world, whether it be Neanderthals and Homo sapiens, Neanderthals in Eurasia, Homo sapiens in Africa, could have independently evolved, let's call it full-blown language. And that, if you went back to their common ancestor some 800,000 years ago, there wasn't a proto-language there or something like that. So perhaps much later, that after Homo sapiens exists, everyone has the components of language, or the adaptations you need for language, and then independently languages emerge.
Yeah, it sounds similar to the discussion we had in episode 189 about dromaeosaurs, and which we've had elsewhere about flight in dinosaurs. That classically we think of flight as this, it's so complex, it's so specific, it showed up one time and then diversified from there. But more and more evidence makes us at least entertain the idea that it is so complex and there are so many components that these were very widespread things, and there may have been multiple origins of flight or near flight like behavior, that there may have just been this cluster of these dinosaurs that were all kind of flighted, and there may have been this cluster of early human populations that were all doing true language or something very much like true language that they were kind of developing independently.
And it feels like with language, you could have an interesting scenario where, because you can have that horizontal transfer, if two different groups came up with two different parts of it, it could then be combined
Yeah.
if they meet.
So now it's much more like the origins of life.
Yeah.
Where did life originate multiple times and then they all just shared DNA and created one unique original starting point?
Yeah.
Language is also this area where it's so at the nexus of biology and culture for humans that, I mean, absolutely there's biological component to it. You are born with the capacity to learn language. So, but you have to be raised in a language environment for that to come to fruition.
Yes.
Right.
Well, that makes me think of stuff like twin speech, which I don't know a lot about, but I know that there's cases of twins forming their own languages with each other that is unique to those individuals and have that that capability. And I don't know if it would be right to call it a drive or compulsion to do so, but like that seems to the same kind of support as what you were just saying.
Yeah, that there's this human drive to communicate and feel like language should exist, right?
Yeah.
Right. Well, that we
there
need
are
to
things in my
communicate.
head that I need to get into your head.
Yes.
Yeah, that we need to communicate, and we have the pieces to do a language. So if we're not presented with a language, we might just come up with one.
Yeah.
One will sort of naturally form from our innate tendency and ability to communicate.
Because we're already making noise. Babies come out doing that.
Yep.
Like, so it's, I might as well put meaning behind it.
Yeah, one of those experiments we could do if we had no, ethical constraints or
Sure.
Yep.
Of course, raising people without language and seeing what happens.
Yes.
Well, and it is one of the places, like you were saying, language is so much a product of biology and culture. It is one of the biggest areas where this differs from studying the evolution of flight or studying other behaviors like that this is intrinsically tied not only to what makes us human, but to what makes us people.
Yes.
And so you run into these questions of where is it appropriate to investigate certain questions in certain manners? Where is it appropriate to speculate on what early languages were like? Like you mentioned the caveman speech, which is often a very sort of derogatory way.
Yeah, cartoony.
To refer to things. It's meant to, oftentimes in popular media, to indicate a lack of intelligence or a lack of culture. And so we run into all those hang-ups that come with wanting to understand things, but also needing to be respectful and mindful that the people we're talking about are people.
Yes.
So from that discussion of sort of early origins, early evolution, and thinking forward about how language evolves over time, Bridget, can you comment on at least a bit on how language continues to develop and evolve over time from those early origins?
Yeah, we do speak of, so this is now, once language emerged, how has it changed over time? So evolution of languages.
Sure.
And very much, the model is just like in evolutionary biology, we're imagining this branching tree with changes in the meaning of our sounds over time, the specific sounds that we make in a given language, all the different ways language can vary and that we see them varying today can change over time, but through processes that are akin to biological evolution. So mainly with language, people have focused on demographic factors. So how many speakers are there? How spread out are they? How much are they talking to each other? And that's easy to imagine, right? If you are spread out across the Eurasian steppe and only see those other people once every 200 years, your language is probably going to just through drift change over time. people tend to get lazy with their mouths, and so there are
Yeah.
some predictable transformations of the sounds that we kind of drop and don't make anymore when you would compare a language that is, known from historical records and how it has changed over hundreds or thousands of years.
Yeah, kind of expectant patterns of developing slang.
Yeah. And then there are, some ideas out there that people test by comparing languages in different environments and,
Mhm.
how much influence the environment has had. People have hypothesized that, for instance, in colder or arid environments, there will be less complex languages like tonal languages because you need like your throat and your mouth to be moistened. And if you're in a very dry area,
Hmm.
it's hard to make sounds that differ subtly.
Mm-hmm.
So, people have tested that by saying, does that actually correlate? But haven't been able to kind of play it back in time.
Yeah. Interesting.
And then, of course, there's historical factors of that we all know: wars, invasions, migrations, colonizations that are, actively telling people to stop your language, and ending it, forcing a language upon another group, or just having neighbors that you're borrowing words from, you're mixing, you're mingling.
Mm-hmm.
And so all those forces are why languages aren't, ticking along at a predictable rate in terms of how they change, but, changing as social environments change, as maybe perhaps physical environments change, and that different human societies clashing.
Yeah. In some ways, studying language is sort of akin to studying artificial selection
Yeah.
processes
Yep.
because there is this degree of intentionality in some cases to the evolution of language that sometimes we on purpose say, let's make this change to language.
Yes.
Or sometimes we on purpose say, let's drive this language extinct,
Mm-hmm.
right? That's part of colonization. That's part of genocide. That's part of the way cultures interact with each other, is to either intentionally elevate certain aspects of the language as a society we've decided to do this, or to intentionally remove or erase some parts of language.
Yes.
And studying the evolution of languages, historical linguistics that we talked about basically goes back at best 10,000 years.
Mm-hmm.
Written texts, go back several thousand years in different parts of the world, about 5,000. So there we are between about 10,000 years and then that 7 million years that I told you it all might have started after we
Mm-hmm.
split with chimpanzees. So we have a pretty big window between when the evolutionary origins of the first language or languages appeared and then when, we can start to see how they're changing over time once we know they're, humans all over the globe are speaking them or signing them.
Yeah. Yeah. It's a realm with a lot of open question, like so many things, behavioral things, especially when we
Yep.
study the past, questions that unfortunately we might not get a lot of answers to
Yeah.
beyond a certain point.
Well, because like it's hard to track and keep up with the shifting of languages today, like with the ones that
Right.
you're alive, from generation to generation, you have those moments of like, what are they saying? Like that, those are my kids.
Right.
What are they saying?
And that's actually, yeah, the other factor that's changes languages is technology.
Mm-hmm.
Yeah.
And I mean, so, obviously today we could talk about how we could talk to anyone around the globe on Zoom, and that will lead to some globalization of languages, US media being spewed all across the globe
Mm-hmm.
spreads English. But much earlier than that, of course, writing was a technology that
Mm-hmm.
Sure.
made it so some languages could preserve even after no one speaks them, and other languages that don't have writing, if no one keeps speaking them, then they disappear.
Yeah.
Yeah. One more note that I want us to touch on and to end this discussion on. We've been talking about how we study language. Something that we often do. We do this a lot in our alley episodes where we talk about plants and particular innovations in plants. And I like to ask, how did it change the world?
Yes.
And I think there's a very similar question to be asked with language. Language isn't just a thing that has evolved in humans and has evolved over time that humans happen to have. language is something that has been immensely influential in human evolution. Just to sort of end us off, would you like to comment on the importance of language for human evolution?
Mm-hmm.
Sure. I mean, as alluded to earlier, it's my favorite human adaptation or skill that we have.
Mm-hmm.
It's a good choice.
As someone who talks and writes for a living, certainly it's essential to my survival and reproduction and my means of acquiring food in the end.
Yep.
But it's a little bit flippant, but go for a day without using language and tell me how it goes for
Yeah.
you.
Yeah.
And looking back over human evolution, we would not have the technology we have today without it. And really, that's ramping up as soon as you can imagine a technology that is so complicated that you couldn't just watch someone doing it and learn how to do it yourself from observing the steps it takes to make it. But once you need someone to explain what they're doing a little bit, to teach a little bit, you need language.
Yeah.
And that's probably, earlier than some would think, that with some of, stone tools, the type of stone tools that Homo sapiens and Neanderthals are making, I would say language is going to be important for learning how to make them. Some of the other things we know those early humans made, probably required language to explain things that aren't evident from watching.
Yeah.
Especially with a lot of those tools being so consistent. Like, that's like, we can tell that this was made from this time or by these people because they're a very consistent thing. There's no way everyone was trial and erroring those individually, like, because then you would have a different form of it for each person that figured it out on their own. They have to be learning those very particular, precise skills from another person.
And like we were saying before, language has been very important in maintaining the structure of societies and cultures.
Yeah.
Once your group gets to a certain size or a certain complexity of behaviors and systems, language becomes essential for holding that together and maintaining it.
Yeah, I mean, if I really had to groom everyone who I interact with, just
Your fingers would get tired.
Carpal tunnel all
Right?
over the place.
And assuming I had, the cognitive capacities that I have now, it just wouldn't be very, satisfying. I enjoy having conversations,
Well, Bridget, thank you so much for joining us, for languaging with us about language a bit for our audience. Audience, please language at us your feedback and the things that you liked about it or want to hear more of. Obviously, language is a colossal subject. If our listeners are interested in learning more about linguistics and the anthropology and paleoanthropology studies of language, there are tons of podcasts about linguistics. There's tons of great ones. Check them out. I always like to plug origin stories because it's a great source of information about how we became human. Bridget, you're involved in Sapiens, which is another great resource for learning about the development of humans as we know them today.
Yes, it's a great magazine written by anthropologists for diverse publics.
Anthro enthusiasts.
Yes, for humans.
For humans, yeah. We're writing about humans for humans and
Yes.
about
By
closely
humans.
related primates.
Yeah. Before we wrap everything up, there is one last section in our episode, and that is our patron question. One of the benefits that our patrons can receive at a certain level is the ability to submit questions for us to answer here on the podcast. I have selected an anthropology-related question for this episode, Bridget, that I thought it would be fun to have you join us in answering. Eric says, I was watching one of the new Jumanji movies, and it got me thinking, how would paleoanthropologists classify the fossils of Dwayne Johnson and Kevin Hart? For those of you who are not familiar, Dwayne Johnson and Kevin Hart are two humans of very different stature.
Yes, big and small.
If there wasn't DNA or cultural context, Eric continues, what are the chances they would be identified as different species?
That's a great question. And in fact, a very similar question was on a midterm I gave this semester. Not with these particular actors, but fossils that I made up and described in this. And I asked the students, how would you know if they were two different species or two sexes of the same species, a small variant and a larger variant, or individuals of different ages. So those are all, three reasonable hypotheses why you'd get a similar looking skeleton in terms of overall shape, but different sizes at a given time and place. Having the DNA would be great. Also, on my test question, there was no surviving DNA.
Cool. So Eric's asking the right questions.
Yeah.
But so for the age question, what you can do is look at parts of the body that develop over time, and particularly the teeth. Teeth are wonderful in humans. They come out of your gums or erupt at a very predictable rate. You got your third molars around age 20, or you had to have them surgically removed as wisdom teeth. But all of the teeth in your mouth come out like plus or minus a year. And so you could look at that mouth and say, does Kevin Hart have all of the teeth? Or if not, maybe it's actually a child who's still growing up to become a Dwayne Johnson size creature.
Yes.
So that's the age one. For the question of sex, it's hard from skeletons, but if this is, if one is a egg producing variant of a species and one is a sperm producing of a species, in some species they tend to be very different sizes. Not all species. In Homo sapiens, it's not very pronounced, but you could look at other features of that skeleton that tend to vary between males and females, like the shape of the pelvis, and try to estimate if one looks more female-like, one looks more male-like. But of course, you'd have to have other skeletons for comparison from the possible species. And then you basically say, okay, just how different are they? And let's look at a bunch of different species, and can any species vary this much?
Yes.
Let's look at gorillas and chimpanzees and any other relative comparative species and say, can they differ in size this much?
Yeah, this is something that has come up before in discussions on the podcast. We run into this same question in other species as well. When it comes to dinosaurs or what else, we run the risk of being confused by different growth stages of a species or different sexes of a species. We've talked about, in episode 98, we talked a bunch about species concepts.
Yes.
And how sometimes it does just come down to this much difference is what it takes for us to say this is a different species.
Yes.
Typically, like you were saying, Bridget, it's very helpful to have context, to have a whole variety of skeletons representing whatever this species is, or to have other evidences like DNA.
Yeah, if we found a bunch of other skeletons that ranged in between those two sizes,
right,
it might make it much more clear that they actually do fit together as a group.
Right. If there's a Jack Black in there,
yes.
and there are these other individuals. Thank you, Eric, for submitting that intriguing question. Thank you, as always, to all of our patrons for supporting us. That's all for at least this episode's worth of discussion. Listeners, be sure, if you're interested in diving deeper into this, to check out the blog post on our website. After this episode, we will put images, we'll put links. We'll have Bridget send us some links, if you know of any, that we can put in the blog post to share for more information. Don't forget that there are other fun things going on with Common Descent. We've got our Spotlight 2024 series coming out throughout the year, where we're talking to other paleontologists and podcasters. Also, Croc and Snake Month are coming up, so stay tuned for information about that. A big thanks to all of the people who requested this topic, and of course to all of our patrons for supporting us. Special thanks, as always, to our top tier patrons, Sarah May, Melissa, and Danielle, the Bug Lover. We release episodes every fortnight. Stay tuned for more episodes. And one more time, Dr. Bridget Alex, thank you so much again for joining us and for helping us to talk some paleoanthropology, which we don't get to do very often on the podcast.
Talk about talking.
Yeah, thanks for having me.
And that's all the language we have for this episode.
Yes.
Bye, everybody.
Bye.
Thanks for listening to the Common Descent podcast.
You can follow us on Facebook, Twitter, YouTube, and check our WordPress blog for pictures and links after each episode. Huge thanks to our patrons whose support helps keep this podcast running and who get access to bonus goodies on Patreon. The song you're hearing is called On the Origin of Species by Protodome, which we found at ocremix.org. Thanks again for listening. We hope you'll join us next time.